A practical example is when you are calling a data from an API, okay, or downloading something from the internet. If you initiate the process, because the download process may take a time, if you are using a synchronous method, okay, operation, then what will happen is that your whole computer would be unresponsive, or your application, it will not be able, you will not be able to respond to anything, click anything. So it will freeze. You will think it is frozen, but then that is how, yes, we'll use the term is frozen. So it will hold the whole application till that particular execution is completed before it releases whatever operation, other operations that you want to do on the interface. But then its counterpart, which is asynchronous, what it does is directly opposite what the synchronous does, which means that anytime you define a block of code as asynchronous and then an execution hits that block, and that block has to take some amount of time to finish the execution, what happens is that it will continue to execute other block of codes below it till that particular block of code is done with its execution. Then it comes to join the process and continue with the process. So in that way, your application still stays responsive. It stays responsive till everything what is done. So you can see the difference. Now, even though we are advising on asynchronous methods or functions, there are times that you would also require, in certain smaller areas, you will also be requiring certain synchronous operations. Okay, there are certain operations that you require that at least a result must always come back for you to check the result and make sure that the thing is legit before it processes on. Something like a user authentication, right? You are logging, and you created an application that requires a login details from an API on the internet. Now you wouldn't want it to continue to open other parts of the application whilst it is not fully checked the login details. So you would want to hold on, pause, and make sure that execution is complete. You have cross-checked to make sure that the person's username and password is correct before you continue with the execution to open other parts of the application that the person can access. So we are not doing away with synchronous, but then you have to minimize it. There are certain few scenarios where you would want to use synchronous, where the thing must hold on till something is done before it continues. But most of the times we focus more on asynchronous operations, especially when it comes to trying to retrieve a lot of data from a database. Even on the local computer, when you are fetching data from the database, you need to go through an asynchronous way so that the entire application will not be frozen whilst data is being retrieved from the database. So that is the concept of that. Now I'm going to use this block of code you have in your handout to explain the concept for you to understand in a basic form. But as time goes on, we'll be building on it. We'll be doing a lot about async operations, okay? Async await operations in our development. And then we also have the promises, callbacks, and so on. We have them in the process. So we'll be looking at all that. Good. So a practical example is this. Let's say we are setting a timeout. Now a timeout is a timer function, even though it's not strictly JavaScript, but then we can use it here to actually see what we're trying to talk about here. So when I say timeout, set timeout, okay? Now set timeout takes a callback function which goes this way. This is a callback function. So I'll hit enter, close it, and then it has a second parameter which is an number of seconds that you want it to wait. Okay, so if I say 1000 is 1 second. So our clocks, you see our clock, when you watch your time, that thing that blinks, or the hand that moves, this longer one, the thin one that moves, that is 1 second. So that is 1,000 milliseconds, right? That is thousands, yeah. So it gives you 1 second. So that is how it's going to operate. Now when I do 2,000, it means 2 seconds. Do 10,000, that is 10 seconds, and so on. So this is just 1 second. I want to do it to be 10,000 seconds so that you can see the difference. And then we want to print something out. So this is the normal behavior of a set timeout, where it is a function which has a callback, what you want to actually bring out whilst the time you have specified expires. So I want to console log its time up, okay, or the time is up. Let me do this. The time is up. So when I execute this, look at what will happen. This, my console execution will not execute. I won't see anything now till my 10 seconds. So let's work that. It just printed a number there, but you can see there's nothing showing here, and I'm not typing anything, I'm not clicking anything, I'm just waiting. You see, automatically it brought it by itself. So it waited that number of seconds and then printed that value in there. So we can use this process to actually hold an execution, a process, hold it on for some time till the whole execution is done, right? So let's go in here and do this. So I'm going to create a function. I'll create a function and call that function and do so many things in here and use that to explain the process. So we do a function. We can also do an arrow function where I can do const. Okay, when I do const, I say I'm going to call this function something like anything. So do job, okay, or do something. Let me call it do something day. Then we have this here, equal, and then an arrow function. Now I'll do this and come down, and then let's say I'll console log one execution, the first execution, and say this is the start point, right? So I'm doing this is the start point, and then the next step will be a set timeout, and do the callback function again inside it. So a function inside a function, and do console.log inner execution code, right? Inner execution code. So I'm console logging that also. Then I'll close my curly brace, bring a comma, and then do my timeout. So let's say my timeout will be 15,000. Then I'll close this. Then I'll do enter again, and then I'll do another console.log and say this is the end of point, right? Then I'll hit shift enter and then close the whole block here. I'll have to close it with my curly brace and hit enter. So what I've just done is that under normal circumstance, you know, any programming execution goes through a process of this nature. It will execute this code in the console, print it out in the console, move to the next block and print it out in the console, and then move to the next block and print it out in the console. But because our application is asynchronous, we have a set timeout which is asynchronous, right? It's an asynchronous function. So what will happen is that instead of waiting to execute this before doing this, it would, because this will take some time to execute, it will print this and skip and print this before, once this is done, then it will come to print it out. So how do we do that? We'll have to just call the function calls do something. It's a function, so you put a parenthesis in front. No, but this one is it's an arrow function, so we can just simply call it by calling the variable we have just created direct. So I'll hit this like this, and this is what comes out. Okay, so let me do the do something as a function and call it, and look at this. Look at what is happening. It's done the start point and end point. The inner execution has not yet popped up, and I'm not touching anything yet. So it gives us about 15 seconds, and then it does that. You can see. So because it's asynchronous, it was able to it did not block the execution of this block of code. No. It went ahead to print the last part, okay? And whilst it is still performing the operations of this, and the moment this got itself done with the execution, what did it do? Then it came to print the result in the console. So it is the same way if, let's say, I'm loading something on a page, and at the same time I'm trying to retrieve some information from the database. When I use an asynchronous function, okay, what will happen is that the page will still load and be interactive, right? Whilst the execution happens behind the scene in the background, and the moment it's done performing the execution or retrieval of data from the database, it populates my interface with the data. In that way, the user experience is great, right? The user feels he or she is able to interact with the interface, because people get bored when they all of a sudden they have to sit for about some 5 seconds to 10 seconds waiting for the buttons and so on to release on the interface to be able to access them. So it becomes, the user experience becomes so great where they can actually be interacting with the interface whilst the application also performs some operations behind the background. So like I told you about login, what you can do to notify the person is that you can show a progress bar on the interface, even though the thing is happening behind the scene and the user is required to get him or herself authenticated before they can move on. You can show something in the form of a progress to tell them that the execution is going on, so they wouldn't be sitting down to think that the entire application is frozen, right? Some may not even be patient to wait till it's done, but rather try to shut down the entire computer before realizing that, oh no, the thing is actually performing some actions in the background. So using a progress bar or a progress indicator on the interface gives them some comfort that at least something is working, something is being processed in the background, so they have to wait a little bit for it to finish for them to be able to interact with the interface. So that is how the callback, the asynchronous functions work. Under normal circumstances, we have something we call callbacks, and these callbacks actually delegates one block of information, it passes on to the other, and then to the other, and to the other, and so on. But by using these promises where something will be executed and then once it's done it comes back and give you the result, it makes it easier to manage and easier to work with. Because let's a practical example, let me create a function here and do this. So const let me call it my function 1, okay? And then let's say I'm passing in a number 1, number 2, And then once this value comes in, it is going to perform an